Hi everybody, this is Mrs. Ewald signing in, and welcome to our new unit on acids and bases. So Unit 10, we're getting up there. We have just previously talked about equilibrium, and we looked at how when you have something that's reversible, the amount of reactants turning into products is also should be, when you're at equilibrium, at a constant rate of your products then turning back into your reactant. So we were looking at this dynamic relationship, how things were moving back and forth. Now with acids and bases, what we're going to be looking at now is the movement of hydrogen ion. And so when you have something that is acidic, we're really looking at the amount of hydrogen ion that's in solution. Now you should be able to put your thinking cap on and remember from last year in biology, no matter what biology class you took, we talked about pH. You might have done a lab on pH, you might have looked at some indicators, you might have tried to do a scale for it, but you should in some way remember acids and bases. And so now we're going to first, though, intro in this first podcast that you're doing tonight what acids and bases are, and then in your second podcast that you should be doing tonight will be strictly on pH and how to calculate that. So just a quick intro, acids. So acids are typically sour tasting. These are mostly what you have in your food, things that give you indigestion and heartburn. But these are basically found in food products. And what makes something an acid, when we talk about this in chemistry, we're talking about it donating a hydrogen ion. Now hydrogen, you should remember, hydrogen within its atom has one proton. And so if you have one proton, you would also have one electron. When you have a hydrogen ion, we write it like this, H+, meaning that it lost that one electron. And so hydrogen, we're going to equal then as a proton, because it's going to have that one proton in its nucleus. So here, let's look at an example of a reaction. So we have hydrochloric and water forming chlorine ion and what is called hydronium ion. Now, if you don't already know, hydronium is water plus one extra proton, which is why it's H3O+. Now, what you're going to need to be able to do is look at a reaction like this and be able to identify what is the acid, what is the base. And let's talk about that first. So the acid is always what is going to be donating a hydrogen ion. The base is going to be accepting. So the acid donates the hydrogen ion while the base accepts the hydrogen ion. So accepting the electron, okay? So taking it in. So looking at hydrochloric and water, this is like the before, and this is the after. So this is what happens before the reaction, this is what happens after the reaction. You want to be able to look at both sides of the equation. So hydrochloric, in order for hydrochloric and water to form chlorine ion and hydronium, what had to happen? Well, this hydrogen ion, so this hydrogen, had to donate itself to the water in order for you to see hydronium as a product, because it took in that extra proton. And the chlorine ion that we see here, we see it here because it lost a hydrogen from the hydrochloric. And so the way then to show this is that hydrochloric is going to be my acid because it donated the hydrogen to water. So water becomes my base. Now we could also look at this in the other way, so in the other direction, and we refer these then as conjugate acid and conjugate base. So these are your acids and bases in the reverse. Oops. So if I were to look at this now, in the reverse reaction, hydronium, in order for me to go back to water, would have to donate its hydrogen to chlorine ion. So this would make this the conjugate acid, and chlorine is going to be taking in the hydrogen, so that would be the conjugate base. Okay? So you need to understand what an acid is, how we kind of define it, and also be able to identify acids within a equation. Now, bases, what you should know, these are slippery when you touch them. We also call them kind of ashy because they have that kind of like slippery feel to it. And so they're going to be found in cleaning agents. These are the ones that are accepting the hydrogen ion. And so here's another example. Let's practice. We're going from water and ammonia forming hydroxide and ammonium, NH4 plus. So it takes in the hydrogen ion, so ammonium ion. So to identify this again, let's think about your before and after. So let's practice it. We're going from water to hydroxide, and the ammonia is going to be taking in a hydrogen ion. So in this case, our water is going to be our acid, and our ammonia is going to be our base. So in the reverse, the ammonium ion would have to donate the hydrogen ion to the hydroxide. So this is the conjugate acid, and the hydroxide would have to take it in order to make our water. So this would be the conjugate base. So hydroxide, you should remember, is one of your polyatomics that you had to memorize. Now let's quickly talk about amphoteric compounds. These are chemicals that can behave as either an acid or a base. So I think you could already kind of identify how water could be either one, because water can form into hydroxide and water can also form into hydronium ion. So let's look at another example using water. So amphoteric is any of those compounds that can behave as either an acid or a base. So let's look at this one. Here, again, comparing the two of what we already saw, this is when it's the base, this is when it's an acid. And so this is exactly the example that I had given you previous to. What you should think about, though, would be other two examples that you could come up with to show how water may be amphoteric. So doing it with another compound, that would be a good practice. I already discussed this prior to, but this would just be the definition in case you didn't already write it down. So going through what a conjugate acid and a conjugate base are. So reverse acid, reverse base. And so just a reminder, remember, acids donate a proton and bases accept. ACCEPT. Okay. Now, let's do one example, or a few here. Let's see. Let's look at hydrogen fluoride and water yielding hydronium ion and fluorine ion. So, going from before and after, I kind of like break it up. How would I go from this to this? Well, I had to lose my proton. So this makes this the acid, and that makes water my base. Going in the reverse then, the fluorine would have to take in a hydrogen to produce hydrogen fluoride. So that makes then my hydronium my conjugate acid, and my fluorine ion my conjugate base. Let's do one more. How about H2SO4 and water, yielding HSO4 ion and hydronium ion. Oop, and it's thinking. I don't know what I just did. Okay. So H2SO4 is going to be forming then into HSO4 minus, so it had to lose a hydrogen ion. So that makes this the acid. Water had to take it in, so that makes that the base. Going in the reverse, my conjugate acid is what it's going to be donating, so that would be the hydronium, so this is my conjugate acid. And then HSO4 minus is going to be my, oops, let me put that in blue, conjugate base. All right, so at this point you should understand what an acid is, what a base is. It's all about moving the proton back and forth, so it's the movement of the hydrogen ion. We're able to look at that with these equations. You should be able to identify acids and bases as well as conjugate acid and conjugate base. This is Mrs. Ewald signing off. Please make sure you continue on to the pH podcast, and peace out.